Have you ever just stopped and thought about the invisible architecture that, basically runs our entire world? It's not built with steel or concrete. It's made of signals and data. A silent, incredibly powerful web connecting billions of us every single second. So today, we're going to pull back that curtain and take a look at the hidden world of computer networks.
I mean, really think about it for a second. You tap send on a photo, and bam. In the blink of an eye, it just appears on your friend's screen, maybe thousands of miles away. It feels like magic, doesn't it? But how does that actually work? What is the journey that little picture of yours actually takes?
Well, you guessed it, it's not magic. It's an absolutely incredible global system of interconnected devices. And in this explainer, we're going to map out the blueprint of that system, all the way from the device in your hand to the satellites spinning around in orbit. Okay, let's dive right in. At its absolute most basic core, this is it. A computer network is simply two or more computers hooked up so they can talk to each other, so they can exchange information. That's it. That's the fundamental building block for everything that follows, whether it's happening in your living room or spanning the entire globe.
So let's start by thinking about scale, because networks come in all shapes and sizes. We're going to do a big zoom out, starting with the network that is probably closest to you right this very second. This is what I like to call your personal data bubble. You know, when you connect your wireless headphones to your phone, or you plug your phone into your computer to transfer some files, you've just created a personal area network, or a PAN. It's super small, it's simple, and it's all about connecting your personal gadgets. Okay, now let's zoom out a little bit to your house or your office. That's a local area network, or LAN. It's that web of cables, or more likely these days your Wi-Fi router, that links up all the computers, printers, TVs, and everything else under one roof, letting them all share stuff and talk to each other easily. And taking another step back, we get to the city level. A metropolitan area network, or MAN, is what connects different LANs all across a city. So think of it as linking the networks of, say, a big university campus, a hospital, and the local government offices, creating this high-speed web across an entire urban area. And finally, the big one, a wide area network, a WAN. This is what connects everything over huge distances, linking cities, countries, and entire continents. We're talking undersea fiber optic cables, satellites, the whole shebang. And here's the key takeaway. The internet itself, it's the biggest, most complicated, most incredible WAN on the planet.
Okay, so we get that networks exist at different scales. But how are the computers inside them actually arranged? That arrangement has a name. It's called a topology. And you can think of it as the blueprint for how all the data gets to move around. So first up is the bus topology. Just picture one main road, and every single computer is just a stop along that road. All the data travels up and down this one cable. Now, it's really simple and cheap to set up, and this is a big but, it has a huge weakness. If that main cable breaks anywhere, the entire network goes down. Game over. All right, next is the one you'll find pretty much everywhere today. The star topology. Here, every computer connects to a central device, like a hub or a switch. This is way better, because if one computer's cable fails, no big deal. The rest of the network keeps right on working. The only catch, that central hub is the single point of failure. If it goes down, then everybody is disconnected.
Then there's the ring topology. This one's kind of like a polite one-way circular street. Data travels in a circle, from one computer to the next. It often uses a special signal. Think of it like a talking stick, called a token, to make sure only one device sends data at a time. It's neat because it prevents data traffic jams, but it can be pretty slow because the data has to hop through every single computer to get where it's going. And this is the beautiful chaos that makes the internet work, the mesh topology. In a true mesh network, every single computer is connected to every other computer. Yeah, it's complicated, it's expensive, but it is incredibly robust. Why? Because if one connection fails, the data just says no problem and finds another path. This exact redundancy is why the internet is so resilient. There's no single point of failure that can bring the whole thing crashing down.
All right, we've seen the different sizes, and we've looked at the blueprints. Now, let's get into the physical hardware, the actual nuts and bolts that bring these amazing network designs to life.
These are the four main characters in our story. You'll find them in almost any network, and each one has a very specific, very important job in the complex dance of getting your data from point A to point B. Let's break down what they do. Now, this is a really important difference. A hub, well, a hub is dumb. It's like a town crier. It gets a message and just shouts it out to everyone connected, whether they need to hear it or not. As you can imagine, that creates a ton of unnecessary noise. A switch, on the other hand, is smart. It's like a postal worker. It actually looks at the address on the data and delivers it only to the one computer it's meant for. So much faster and way more secure.
So let's trace a packet's journey. It starts with your computer's network interface card, or NIC. That's what sends the data out. If the data is for another computer in your house, your switch directs it right there. But if that data is going out to the internet, the switch sends it to the router. The router is the gateway, the bouncer that connects your little local network to the massive wide area network.
And just to round out our hardware tour, there are a few other specialists worth knowing. You can think of a bridge as just a simple connector that joins two similar local networks together. A repeater is basically a signal booster. It gives the data a little push so it can travel farther without fading out. And a gateway is the master translator, this really clever device that allows two completely different kinds of networks to actually understand each other. Of course, these days, so much of our networking doesn't involve a physical cord at all, right? So where does Wi-Fi fit into this whole picture? Let's take a look. You know, it's funny, Wi-Fi is actually just the brand name for a technical standard called IEEE 802.11. Over the years, that standard has gotten a whole lot better, with new versions giving us way faster speeds. You've probably seen those letters on your router, like G, N, AC, or now AX. Each one just represents a big jump forward in performance. The heart and soul of any wireless network is the wireless access point, or WAP, which is really just what we call our router at home. It acts as that central hub in a wireless star topology, broadcasting a signal that all your devices can connect to, usually within a range of about 50 to 150 meters. So we've got the networks, we've got the hardware, we've got the wireless signals. Let's look at the final piece of the puzzle, the actual technology that brings that massive wide area network, the internet, right into our homes. Oh man, for some of us, this is a real trip down memory lane. It all started with dial-up, that awful, beautiful sound that many of us will never, ever forget. Then we got upgrades like ISDN and DSL, which gave us an always-on connection. And that evolution has just continued at a breakneck pace, leading us to the cable, fiber optic, and 5G connections that literally power our world today. You know, when you step back and look at it, from a simple cable connecting two computers all the way to a global mesh network that underpins our entire society, this architecture of connection is truly one of humanity's most incredible achievements. We built this. So the real question is, now that we know the blueprint, what are we going to build next?